These vibrant colors reveal what gases nebulas are made of.
So, for example, if there's oxygen gas, you get a green glow. If there's hydrogen gas, you get a red glow. So, analyzing the light from a nebula turns out to be very instructive. It tells us what's there. It tells us what the physical conditions are. We can tell how dense it is, how hot it is, and what it's made of. We can find out a lot about the neighborhood by looking at these clues that come directly from the glowing gas.
The gases glow at thousands of degrees, heated from a mysterious source hidden deep within the nebulas. To figure out what the source is, we need to peer deep inside.
But of course, the gas and dust is in the way. So it's not so easy. It's a very mysterious part of the galaxy. It's a place that we have to use these special tricks to look into.
And Kimberly Weaver is an astrophysicist who's got a few tricks up her sleeve.
I've got a really neat way to show you this. This is a bag that you can't see through with your eye, so a normal telescope that looks at optical light could not see through this. In infrared light, a telescope can see through it. The infrared camera, if I put my hand inside, can see my hand. I'll wiggle my fingers to show you that you're seeing the heat from my hand inside the bag. And this is just like a star that's hidden inside a cloud of gas and dust that infrared astronomers can detect by using an infrared telescope.
This is a picture of the Orion Nebula in visible light. We can see all of the gas here located in front of what we know are stars in the background. And we want to be able to look inside this nebula and see the stars. In infrared light, in this image, we can now pick out the stars inside the nebula. And we can see dusty cocoons around the stars.
But scientists still need a way to strip away the remaining dust.
How do we get rid of all this haze and fog? The way to do that is with an X-ray picture. Now when we transition into the X-ray image, you can see just the stars themselves. The X-rays coming from the surfaces of the stars. And now we can study them in great detail.
By analyzing the light from these stars, astronomers make an astounding discovery. Hidden within the Orion Nebula are some of the youngest stars ever found. Stars just a few 100,000 years old, a mere heartbeat in the life of the galaxy. And it's not just the Orion Nebula. Nebulas house baby stars in every spiral arm of the galaxy.
These regions are the nurseries for new stars. There are young stars in these regions that are heating up gas clouds that surround them and making those gas clouds glow pink.
Stars are made out of gas, basically, and our galaxy has gas. In fact, our galaxy, you can think of it as having an atmosphere of gas and dust that surrounds all of the stars that we see in the disk. And it's from this gas that new stars are born.
By observing nebulas at different stages in their evolution, the story of a star's birth begins to emerge. It all starts inside a cold, dark cloud of dust and hydrogen gas, where a quiet tug of war begins. The cloud wants to dissipate, like smoke in the air, but gravity wants to pull it together.
They're in a kind of balance between gravity pulling in and gas pressure pushing back out. Gravity wins, and the material crunches down into a disk that is the beginning of becoming a star.
As gravity pulls more and more gas towards the center of the disk, it gets denser and denser and hotter and hotter. Until finally, at 18 million degrees, a miraculous transformation takes place. Hydrogen atoms fuse together to form helium, and with a burst of nuclear energy, a star begins to shine.
These stars eventually get their nuclear fires going in the core, and when they do, they heat up. They can expel the material that's around them so that it kind of clears up the neighborhood.
Over the next few million years, winds blow the surrounding gas into spectacular swirling patterns.
It blows away the gas, it blows away the dust, and it lets us see this beautiful new thing, this place where the star has been born.
A human lifetime is too short to witness the wonder of a star's birth in the spiral arms. But by speeding up millions of years of cosmic time into just a few seconds, we can see one star born after another. Here and there are even more brilliant flashes of light, coming from some of the most violent and dangerous neighborhoods in the entire Milky Way galaxy. Here, stars aren't born. They die. We're taking the Earth from the familiar neighborhood of the Sun to visit the wonders of the Perseus arm, nearly 6,500 light-years away. Here lies one of the galaxy's most beautiful sights, the Crab Nebula. Although it's made of gas and dust, this nebula hasn't created stars yet. But for Alex Filipenko, this area does represent the industrial zone of our galaxy, where the building blocks of Earth were manufactured long ago.
Look at that molten iron. Holy moly.
The Crab Nebula is a fascinating object. We see these very rapidly expanding gases.
The crab may look static, but gases are racing out from its center at over 3 million miles an hour. Put into motion by a phenomenally powerful and violent event in the past.
When we examine the gases of the Crab Nebula, which are expanding outward, and we extrapolate that expansion backward in time, we find that all of the gases were at a common point about 1,000 years ago.
Back on Earth, 1,000 years ago, early civilizations watched the heavens. In 1054, Chinese manuscripts describe the sudden arrival of a brilliant new star. It shines brighter than any other star, so brightly it's visible during the day. But then, it mysteriously disappears. Today, the Crab Nebula lies in exactly the same part of the sky where the Chinese observed their brilliant star. What they witnessed was the moment the crab was born.
The Crab Nebula was produced by the colossal, titanic explosion of a star at the end of its life. It's a supernova remnant.
The spiral arms of our Milky Way are littered with these colorful remnants. Tombstones of stars that died violently in cataclysmic explosions called supernovas. To figure out this mystery, astronomers need to locate the next victim, a massive star at the brink of death.
It takes supernova light 1 million or even 1 billion years to get here. They're millions or billions of light years away. But they only shine for about a month. So we have this little tiny window to study these things before that light is gone forever.
In the workshop, Howell and his team are busy preparing their telescopes.
Pretty cool. That's right. We're building a network of telescopes so that we can study supernovae in greater numbers, in greater detail than we've ever been able to before. Let me show you the telescopes we're building. These are the 0.4 meter telescopes, and there are 4 of them here, and we're building them, 20 of them in total, and putting them all around the world. So some of these first ones will go to Chile. We have some in Hawaii already. So let me show you one of the bigger telescopes we're building here. Here we have the 1 meter telescope. We're building about 15. The mirror's not here yet, but this is where it's going to go. That will reflect the light we gather from the supernova. We have to be able to point anywhere in the sky. And so you can see that the telescope pivots along this axis and the C-ring moves. The great thing about this kind of observing is that it's totally robotic, and I can just sit here in Santa Barbara and have a beer and pizza while the telescopes do their work. All new discoveries about supernovae from all different places in the universe.
Once they've caught the light of a dying star, the detective work begins.
We collect that light and we analyze it in great detail in order to determine what's going on. What's the chemical makeup of the star? What's the pressure inside? What's the temperature? What kind of nuclear reactions are going on? How does a star explode? All of these things we figured out through the analysis of light.
Astronomers deduce that only stars with a huge mass go out with a bang.
A massive star has a very interesting and vigorous life. Initially, it fuses hydrogen to form helium, and that produces energy. That makes the star shine. Then the ashes of that reaction, the helium, fuse together to form carbon and oxygen, releasing yet more energy. Then the carbon and oxygen can fuse into still heavier elements, magnesium and sodium and neon and things like that. And then silicon and sulfur, and finally iron.
When it starts to make iron, the giant star is doomed. In the core, a fierce battle takes place. Energy pushes outwards, holding it up, while gravity wants to crush it inwards. The battle continues as the star makes heavier and heavier elements, producing energy while fending off total collapse. But once it starts to form iron, the battle is lost.
Fusion of iron nuclei into heavier things does not release energy, it absorbs energy. So an iron core builds up, but finally it becomes so massive that gravity wins. The iron core collapses. In less than a second, the outer layers collapse inward, then rebound and get blown to smithereens.
From this death comes new life.
We're at a foundry here, and they're pouring molten iron from old machinery, and they're going to make parts for new machines out of that iron, so they're recycling it. But all that iron was created and ejected into the cosmos by gigantic stars that